Unit 3.7. Comparing objects using equals, compare to, and equal equal. So what we're going to look at here is just comparing some objects. These answers are Boolean answers, so we expect a true or false. And we're going to look at the string as an object, not written with the literal. Okay, remember earlier on I was talking about try not using the equals for strings and use dot equals instead. And what we want to see here is why. And remember I said equals is a much better method to use because it literally says is this string having the same characters in the same position. When you make the string with the literal, the equal and dot equals will work if the string is made using the object constructor, keyword new. We might find out that we have a different solution. So let's take a look. I have three names here, name 3, name 4, and name 5. Name 3 is Carol, then Blake and Carol. And then I have some prints. I'm comparing 3 and 4. So name 3 dot compare to name 4. So compare to is a method that returns a negative if the name, or I should say the string, is less than, and it returns a positive if it is greater than, and it returns a 0 if they're equal. So let's look at 3 compared to 4. So 3 is Carol, 4 is Blake. Carol comes after Blake in the alphabet. Okay, it's A, B, C. So since Carol comes after, this should return a positive number. And I remember saying I don't want to go into how they actually calculate that in the API, but it's going to be a positive number. So if it's positive, Carol comes after Blake. Name 3 dot equals name 5. So 3 and 5, are they equal? That should return true. Then we're going to name 3 dot equals name 4. That's not true. It should return false. And then when we're comparing the names here, name 3 and 5, let's see, 3 and 5 should return 0 because these are the same. Let's run this and verify. I'm going to scroll down. So comparing name 3 and 4, this guy, he returned a positive value. It's 1. And then when we do 3 and 5 are equal, it says it's true. 3 and 4 are equal. That's not true. It's false. And since 3 compared to 5, they're both Carols, so it's 0. Now, compared to doesn't give us a true or false. It gives us a little bit more information. So it tells us that these two are equal because it's 0. So we know these two are equal. And it tells us that the one says that the Carol comes after Blake if we were to alphabetize them. So not only does it compares, which is something important to do, but it gives us some more information than just equal, right? Because equal only gives us whether these two are the same things based on the definition of equal for that particular object. So in this case, string is saying the same character in the same order. Let's go down. So this makes sense to use these methods as it pertains to objects. Let's check this guy out. Remember before I said don't use him? Let's see. Let me go ahead and check out this. I just want to check out this one here. Okay? Because at this point right now, you may be saying, well, yeah, 3 and 5 are equal. See, it gave me a 0 here. And when we did this, it gave us true. So obviously, this should be true. So we run it. And what do we get? False. Slide this over a little bit so it's nicely in view. False. Ouch. But wait a minute. How come before it gave us true? Well, see, that's what I was talking about, is that this is not reliable. If it were with the string literal that this was created, it would give us true. But because we're creating the object string, that's not true. So because of this confusion, we avoid it. We do not use this to compare strings for equality, or to compare any object, as a matter of fact. We want to use the equals method or compare to method. Okay. Now, this is a little bit more complex than what we're seeing. Let's go ahead and talk about aliases. So let's talk about why this is not true. Even though they're both Carol, they're two different objects. What this is asking is name 3 the same as name 5? No. Name 3 is name 3 and name 5 is name 5. They just happen to be named the same thing. But dot equals are asking is name 3. Does name 3 have the same characters in the same order as name 5? You see the definition of equals there? That definition of equals allowed these two to say true, but allow this to say false because this is literally asking, is this the same as that? They're not the same. They're two different objects. So see the unreliable equal stuff before it was true, and we had the string literal. Now it's false because we have string, and there are two ways to make a string. Well, more than two ways, but these are two ways that we make strings, and we can't rely on this. Let's go down a little bit more. What if I do this? What if I set name 5 to name 3? This is aliasing. This is the same as these two guys are in memory pointing to Carol. They are referencing the same literal Carol. So if I go ahead now and ask if they're equal, let's run this. This is the confusion I'm trying to avoid. See, now it's true. Both are true. And that's because of referencing. It's something called pointers in memory, which Java does not necessarily expose, but I'll tell you about it. Think of it as there's Carol in memory, and right now, after doing this, name 3 and name 5 points to Carol. Okay? So we already see why this one is true. They do have the same number of characters in the same spot, and they're both referencing the same spot, so this is even more true now. And this guy turns out to be true now, because not only are they referencing the same thing, they literally what's called aliases, two different names referencing the same thing. So they're literally the same. So this bit of confusion is the reason to avoid equals equals. See, once you decide to compare strings or objects, dot equals is the way to go. Now, that doesn't mean you can't use equals equals. You can, but you have to understand all these little pieces of nuances and use it right. Okay? So in that case, we want to kind of stay away from it. Now, if you know what you're doing and you do understand it, then yes, you could go ahead and use it, but just be very, very careful. Moving on, I'm going to wrap this up with some nulls. Here we have name 6 that turns out to be null. Hey, see this little error here? It's going to say dead code. Do you know why? Because this is a null pointer. Let's run it and crash it. Null pointer exception. I wanted to show that. If an object is null, you can't ask it to perform an action. Cannot. Okay? That would be the equivalent to saying a unborn child who's not born yet, you're still in your mommy's womb, cry. Impossible. You want to ask an object who is in existence to do an action. Okay? He is not created yet, so he can't do this. So we crash. I'm going to get this out. This is bad code. This is bad code. Okay, we don't want to write null pointers. So let's write null pointer. That's exactly what I was talking about up here. Pointers. I'm pointing towards the same Carol, so that makes us aliases, that makes us equal. Dot equals would work as well. Equal would work as well. Here, I don't have anything yet, so now name 6 can't do anything. But then I ended up nicely with an if statement. Stacked. Stacked if. If name 6 is null, make a new string called Brian, set it to name 6, and if name 4 is not null, See how I'm using the not equal? Then print it and say my name is name 4. So now I have name 6 and I have name 4. So name 6 will be created, but name 6 will not be printed, only name 4. So I'm going to run this. I got rid of the crashing. So yes, name is Blake. Name 4. Let's look back up to see if it was Blake. Yes, it was. Now let's do one more thing before we wrap up. Let's go ahead now and say name 4 dot compare to name 6. Well, let's see. What do you think would happen here? Okay, let's say compare name 4 and name 6. What would happen here? So let's see. Name 6 is Brian. Name 4 is Blake. Which one comes first? Well, let's run it and see. So we get a -6. Whoa, what does that mean? Let's see. It means name 4 comes before name 6. It's less. Okay, negative means it comes before. So let's see. Let's see if that's right. Name 4 is, let's put a note here. Name 4 is Blake. Okay. So does Blake come before Brian? Yes, it does. The B's are the same. That doesn't disqualify it yet. But L comes before R. So Blake comes before Brian. Therefore, we have a -6, right? Because we're comparing Blake with Brian. It's stacked, so we had to check both. It's not nested. And we wanted to check both just to see how the whole thing was working. 3.7, we're comparing objects. Let's recap. Do not compare with equal. It's too unreliable. Like I said before, it's unreliable, and here I'm showing it. Use equals or compare to. I know you may say, well, compare to, that doesn't tell me if it equal. It does. If it gives you a 0, it's equal. So once we're comparing objects, we want to refrain equal. Use the methods to do the comparison, comparing objects, the very end of Unit 3, 3.7. When you're writing your if statements with these, by the way, you would find that you would have a method call inside your if statement, and that's okay if you were to use them. So you could say if name 3 dot equals to name 4 or something like that. So these things could show up inside of the if statement. That's fine. Okay, so just for a quick example, let me write one here. I could say something like this, and nothing's wrong with that. Okay, this is perfectly okay, perfectly legal. If these two names are the same, then do something. That brings us to the end of 3.7.